Welcome back to All This Math. This is Professor Parker. Please make sure you are subscribed to the channel if you haven't already. Please like this video. Go ahead, hit the like button. Also share this video with somebody and drop some comments in the comment section. Go ahead, drop some comments. If you got questions about anything that I explained that you still don't understand, please let me know. If you finally do understand something that you didn't understand when you tried to learn this in class, drop a comment in the comment section. Let me know. All right. So what are we doing today? We're doing some work with complex numbers, and let's read our instructions. It says to simplify the expression to a plus bi form. A plus bi form. Now, first of all, what's the expression? This is the expression. The square root of 4 minus the square root of negative 72. That's a red flag. Minus the square root of 16 plus another red flag, the square root of negative 162. Now, why did I say it's a red flag? Because how do you take the square root of a negative number? Just think about that for a minute. If you really understand what a square root is, right? How do you take the square root of a negative number, right? Let's think about the number 36. 36 is a positive number. Now, we could take the square root of positive 36 because positive 6 times positive 6 equals positive 36. Even negative 6 times negative 6 equals positive 36. But how can you multiply a number, a square root, by itself and then end up with a negative? That sounds crazy. How are you going to do that, right? That's not real. Right? That's imaginary. That's why we use the letter I to represent an imaginary number. Or we say I is equal to the square root of negative 1. Because like this is a negative 72, right? But I could also rewrite that as negative 1 times 72. So the negative 1 part, that being the square root of negative 1, that part is imaginary. That's not real, right? Just like some people are not real. Some people, you listen to them talk, you see how they move, and you're like, yo, you cannot be serious, right? We know they fake. We know they don't stand for nothing. They don't stand on business. They got a lot going on. They probably got some issues, right? But we still have to know, even if you are a real person, right, that does not have the same issues that they have, that does have principles, that does stand on business, we still have to know how to coexist with those people in society, in school, at our jobs, wherever, right? So this is what we're going to do. This is why we use the variable, I guess we could call it a variable, or the term I. Lowercase I represents an imaginary number. An imaginary number is equal to the square root of negative 1. So whenever you see the square root of a negative, you know you're going to be dealing with some imaginary numbers. All right, just get familiar with that, get used to that. You know you're going to be dealing with some imaginary numbers, some letter I's. You're going to see this a lot too when if you're in an algebra 2 class or even an algebra 1 class and you're solving quadratic equations, right? Because sometimes those solutions are not always real. They're a solution according to the methods that we use, but we don't end up with always real number solutions. Sometimes they're fake number solutions or what we call imaginary number solutions. All right, so let's get to it. So what I would do in this particular problem is I would simplify each of these terms one at a time, right? So in order to be successful at this problem, you need to know how to simplify radicals. You need to know something about imaginary numbers, but you also need to know how to simplify radicals. What's a radical? A radical is a number that is within a radical sign. This is called a radical sign. This symbol that kind of look like a long division sign from elementary school, but it's called a radical sign, right? It's giving us information. It's telling us to take the square root of whatever number is inside the radical sign, which we call a radicand. The square root means, okay, what number can be multiplied by itself to give us that number as a product? So what number can be multiplied by itself to give us 4 as a product? That's what that means. Everything in math, every symbol, every letter, every variable, every operational symbol is instructions. That's all it is. This is telling you to take the square root of 4. Now, what's the square root of 4? Ask yourself, what number times itself equals 4? The number 2, because 2 times 2 is 4. So this is going to turn into a positive 2, right? Then you bring your minus sign down. Now over here, this is when things get a little crazy. Not crazy, but a little different. Whenever you see a negative sign, I'm going to tell you this. This is what you should do as a habit. Whenever you see a negative sign in the radical sign, you should separate it from the 72 and write it as negative 1 times 72, right? Now, I'm going to do 2 steps in 1. Watch me work. I'm going to change this to, instead of writing 72, I'm going to change this to 36 times 2, right? Now, what you should be asking, if you don't already know, is why did I do that? And whenever you're in class, your teacher writes anything on the board, Don't just be sitting there just copying everything down, right? Trying to look like you being a good student when you have no idea what you copying down. Raise your hand. Don't be scared to be embarrassed, right? Raise your hand and ask. So right now, this 72 turned into a 36 times 2. You should be wondering, like, why did I do that? The reason I did that is because when we simplify radicals, you want to break the number down if it's not already a perfect square. Like 4. 4 is a perfect square. So we don't got to break that down. We just take the square root. What's a perfect square? Okay, somebody might be wondering that. Let me answer that real quick. A perfect square is when you have a number whose square root is a whole number. 4 is a perfect square because 2 is a whole number and 2 times 2 is 4. 5 is not a perfect square. 5 ain't perfect. You know why? Because the square root of 5 is a decimal. So that's not perfect. 6 is not a perfect square. You know why? Because the number that you multiply by itself to get 6 is a decimal. 9 is a perfect square. Why? Because 3 times 3 equals 9, and 3 is a whole number. So you got to know the definition of a perfect square also to do this type work. You got to know that. You got to know the math vocabulary. All right. Now, when we simplify radicals, if the radicand, the number inside the radical sign, is not already a perfect square, you break that number down into factors where you got one number that is a perfect square. 36 is a perfect square because 6 times 6 is 36. So that's why I broke 72 down. You always want to break the radicand down into two numbers whereby one of them numbers is a perfect square. So then I go over here to this 16. 16 is a perfect square. So we don't got to break 16 down. It's perfect already. So we just take the square root of 16, which is just 4. Bring the minus sign down. Boom, square root 16, that's 4. Then you bring your plus sign down. Now I'm going to switch this up the way I switched this one up. I see a negative sign. Whenever I see a negative sign, I change it to a -1, which is going to be multiplied by. Now I got to ask myself the question. I'm a teacher. I've been doing this over 20 years and went from K through 12 and did a lot of math. So I already know off the top, just from experience, right, that this could be broken down into 81 times 2. Because 81, and why would I do that? Why would I break it down to 81 times 2? I could break it down into other numbers. I break it down into 81 times 2 because 81 is a perfect square, and that's what I want. I want perfect squares inside the radical sign so I could take the square root of them. Just like how I took the square root of 4. 4 was already a perfect square, so I ain't had to change nothing. So what I do need to do, though, is I need to change this 72 into two numbers whereby one of them is a perfect square, so I can take the square root of that number. All right, so I'm going to do the same thing with the 162. That's going to be 81 times 2. All right, so now next step, I don't do nothing else to the 2. I can't, not yet. And then I go here. Now look, square root of -1, imaginary number. Square root of -1 is I. That's going to turn into I, right? So I got I. That comes out. That's going to become I. I didn't mean to do that. That was like a question mark. Actually, it is a question mark. So that's going to be I. And then square root of 36, that's going to come out, turn into a 6. So I got, and then the 2 can't come up. But you know what? Let me do this. So the 36 came out, turned into a 6, right? The -1 came out, turned into an I. The 2 can't come out. It's still in the radical because it's not a perfect square. It can't come out. Bring the -4 down. All right. Now, then we bring this. The 81 is going to come out. What's the square root of 81? You need to know that. Square root of 81 is 9 because 9 times 9 equals 81. The square root of -1 is I. It's I. So you got 9I and then the square root of 2. All right. The beauty of this video is that if there's anything I said you don't understand, you can run it back. Hit pause and rewind, right? Keep watching it. All right. Also, if you got questions there's some things you still don't understand, type your question in the comments. Please type your question in the comment section below. All right. So now, where did this 2 come from? Square root of 4. And this is what you should be doing when you're in class. You should be making sure that you know where everything came from step 1 to step 2 to step 3, because the problem is constantly changing. Every step, every line, the problem changes. You need to know where all the changes came from. Where did this -1 come from? Oh, I separated. The negative sign is the -1, basically. Why did I do that, though? Because I'm trying to simplify. I know the square root of -1 is the same thing as I. So that's going to make things simpler. Where does 36 come from? Oh, I changed 72 into 36 times 2. Why? Because 36 is a perfect square. And that's what I want. I need a perfect square inside the radicand so I can take the square root. That's why I do that. Where does 4 come from? Square root of 16 is 4. Minus 4 again. Where does 9 come from? Oh, 81. Square root of 81. Where did 81 come from? I broke 162 down into 81 times 2. So when you simplifying radicals, you got to know your multiplication facts. You got to know your perfect squares. So you can think, okay, boom, what numbers can I break this number down into? Therefore, I will have a perfect square value that I could work with. I know 81 times 2 is 162. That's why I broke it down like this, as opposed to breaking it down another way, right? Where'd the negative 1 come from? A negative sign is a negative 1. A negative sign is an abbreviation for a negative 1 times whatever number is next to it. So instead of saying negative 1 times 162 in mathematics and algebra, we shorten it and just say negative sign. Just throw the negative sign on it. But you got to, as a student of mathematics, you got to know that that's what that means. Just like with slang, when you hear somebody say a certain thing, you need to know what they mean, right? And that's the expectation. Same thing with math. Math is a language too, right? Now we're going to combine like terms. This is a constant. This is a constant. 2 is what we call a constant because it's just a number, right? This is a constant. All right. This actually might be considered a constant because there's no variable, because I is not really a variable, even though it's a letter. So these are actually all constants, but we cannot combine these constants with these constants because they have the square root of 2 in them. But these are like terms. The square root of 2 terms, they go together, right? The 2 and the negative 4 go together. And remember, we want a plus bi form. So we want the real number that don't have an I in it to be written first. So that's going to be the result of, or the sum, or actually the difference, because this is subtraction. 2 minus 4. 2 minus 4 is negative 2. So we're going to have negative 2, and then we're going to have plus 3i root 2, right? Now, where did I get that from? Where did the negative 2 come from? Always go through this process. Ask yourself, where did this come from? Where did that come from? Where did that come from? Where did the negative 2 come from? Doing 2 minus 4. That's where the negative 2 came from. Where did 3i come from? Ask yourself, what's negative 6i plus 9i? Negative 6 plus 9 is positive 3. So that's 3i root 2. Now, if your teacher wants to be technical, they might want you to write the I term last. So we could rewrite this, if we want to, as negative 2 plus 3 root 2 times I. Just make sure you don't write the I under the radical sign at all. All right. So I don't know if your teacher will allow this answer or this answer. I don't know. If it was me in my class, I would say this is cool. But you never know with some people. But just be prepared, and just also it's important for you to know that this expression is equivalent to this expression right here. All right. So that's how you simplify expressions that involve imaginary numbers. Whenever you see a negative sign under a square root, now, not a cube root, but under a square root, you're going to deal with an imaginary number. It's going to be some I work coming in there somewhere, right? So, yeah, but know how to simplify radicals. I got another playlist that involves videos or includes videos on how to simplify radicals. All right. So practice these. Also, if you're not familiar with Black Wall Street, Tulsa, Oklahoma, the Greenwood district of Tulsa, Oklahoma, which was bombed in a race riot where Black businesses were destroyed by racists in the community back in 1921, in May, actually, of 1921, right? I highly recommend you study that. And also, that was not the only community where that took place at. That has happened throughout the history of the United States in many places, right? So let Black Wall Street in Tulsa, Oklahoma, the Greenwood section, just be one example, all right? But also research other areas and other parts of the United States where that took place too. And also think about the fact that we still here. So that's something to be proud of. We still here, even and we endured all that. You know what I'm saying? So practice this, right? Study Black Wall Street, and I'll see y'all in the next video. Peace.